This is a demonstration of the Neo Virginia Map Maker, which turns a Google map into a pixel map. We're going to go ahead and put in the initial values that I've been using for quite some time now, just as a test. So the initial X is 37,500, the initial Y is 6774, the width is 157, and the height is 137. And we're using a delay per tile of 120 milliseconds, because any shorter than this and we would run into some problems. Okay, we're going to go ahead and initialize the image file. And now we're going to go ahead and start the map capture. And you're going to not want to blink. Now I really ought to add in this scanner noise from Blade Runner, because it kind of looks like that. See, as you can see, it's passing through a map of Arlington, Virginia, a section of Google Maps corresponding to Arlington, Virginia, and it's printing out one line of pixels at a time onto this map, and each pixel corresponds to an area of the map within this cyan square, which looks like a rectangle because of the distortion here. What you got here is it's 248 pixels by 248 pixels, and that corresponds on the ground to 96 feet by 96 feet, or 32 yards by 32 yards. And that's the scale of the game is 16 pixels to 1 yard, because I wanted one tile to be one sidewalk tile. So we're encoding the map in terms of chunks, and so each chunk is going to be 32 by 32 tiles, and each chunk here is represented as 1 pixel on the overworld map. Now what it's chiefly doing here is denoting land versus water. The entire color scheme of the map is reduced so that land is black and water is white. And then it looks for any pixel, it looks for areas here, showing up here, where the average brightness is where the average brightness is not black. Or rather, that is set by this threshold here. And so it takes a 9-point sample across the image, 9 different points in a grid of 3 by 3, averages their brightness values, and if it's more than the threshold here, then it prints out a blue pixel onto the pixel art. And if it's 0 currently, then it stays black land. And eventually this will be able to, well, as you can see, it estimates the time per row, and then it approximates the total time here is 54 minutes to do this entire thing, because it's 24 seconds per row at 120 seconds per tile, or 120 milliseconds per tile. But it's got to do 137 rows, and I really wish that Visual Studio had native support for a vertical progress bar, because then I'd be able to show you that it's only completed these many rows right here on a little falling progress bar. You can't change the threshold after it's been initialized, so there's a safety measure built in for that. But it does it all automatically, and it's certainly a hell of a lot faster than it would be if I were doing it by hand. Certainly a hell of a lot faster. It's also really fun to watch the different rivers of Arlington pass by, although it's still technically encoding stuff on our side of the Potomac, which I think is pretty cool either way. Now, the neat thing about using Google Maps to do this is that the Google Maps JavaScript Developer API, it does require a credit card in order to have, like process charging for different API rate limits and stuff, and they give you $300 credit free when you first sign up. And I don't know if that refreshes monthly. Some of the pages say $200, some of them say $300, but so far I've only incurred like $3 worth of credit in the testing, because they only charge you for each page refresh. So as long as I don't refresh the page, I could load the entire world one tile at a time and they wouldn't be able to do shit about it, which is pretty cool. Yeah. So as you can see, it's right here, it's starting to print out the various, that little stripy bend in the northern end of the Potomac right here, the northern shore. of that part of the Potomac. I'm not actually sure what river that branches off into. I had to turn off all the labels in order to make everything display properly, so that the map would be able to read it in terms of pure brightness. It's a really hacky solution overall, but I think it's pretty cool, honestly. I mean, it looks fly as fuck. So I'm also really proud of the fact that it inputs the coordinates here automatically when you start. So you put in your coordinates over on this side, and it automatically types them in here and goes to that tile. And I say it's really hacky because it doesn't like directly interface with the code of the JavaScript Google Map. What it does is it simulates a key press, and I coded into the JavaScript file key press functionality that would recenter the map over 248 pixels each time the key is pressed. And of course that's all directional here. You can see that it's got instructions over in the top left. So for example, it uses Shift A to jump back to the left side of the map after a row is done. It's just really fun. I'm really proud of the work I've done here. It looks cool, it feels cool, and it does it all for me. And I programmed it in a single afternoon, so I'm pretty happy with the results. Now that's really interesting as well, the way the CRT shows up on the camera. It is indeed very fresh and fly. Yeah, this is gonna take a frickin' while, isn't it? I suppose that's enough of a demonstration. Alright, I hope you enjoyed that. Peace and love, you know? Peace and love. And rad nasty cybertech.